Okay, pretty much everything we do in today's class is in relation to this vector function. I'm not going to read it to you, it's legible. Okay, so what do we want to do? First thing you're asked to do is find r prime of t or v of t. I'm not sure which way it was expressed, but you should know that we can express r prime of t as v of t if we regard t as a time variable, because then the derivative of our position vector is our velocity vector. And then we want to find the unit tangent. We want to find the acceleration vector, which is the derivative of our velocity vector, assuming a velocity acceleration position context. And the component of A in the direction of our unit tangent vector, the component of A perpendicular to our unit tangent vector, and a unit vector in the direction of our acceleration, of the perpendicular component of our acceleration. These are all very, very important vectors for analyzing the motion of something that moves in three-dimensional space. Okay, well, let's just proceed. First of all, r prime of t is easily calculated. When we calculate the derivative of our j component, we've got to use the product rule, but here's what we get, and that should be correct. Our acceleration vector is our derivative of our velocity vector. Our r of t vector is our velocity vector, but of course I could say, okay, v of t equals our r of t vector. In any case, our acceleration vector is the derivative of our velocity vector, which in turn is the derivative of our position vector, so you might see it written that the acceleration vector is the second derivative of the position vector. That should be completely obvious. Okay, if I've taken the derivative correctly, and I believe I probably did, we get this, where in taking the derivative of this expression, we got a negative sine t minus sine t. Negative sine t from the cosine, and a negative sine t when we took the derivative with respect to t. That gave us a negative 2 sine t. And then when we took the derivative of the sine t, of course, we got a t cosine t. The derivative of e to the t, conveniently, just follows on through as just plain old e to the t in every expression. Okay, the unit tangent vector then is what? The unit tangent vector is thought of intuitively as our vector in the direction of motion. The direction of motion is the direction of our velocity vector. So if we take our velocity vector, which I've expressed as the derivative of the position vector, and divide by the magnitude of that vector, which of course I could say is v of t divided by the magnitude of v of t. What do we get? We get, well, the derivative of v of t is our a of t vector. Derivative, our v of t vector is our derivative of the position vector, and we can just copy that vector down from up here. Okay, so this is just, the numerator is just the same as this, and then we have to divide by the magnitude of that, which means we have to take the square root of the sum of the squares of all the components. You got to be a little careful. You know, like you don't want to write down the square of the cosine minus t squared times the square of this, or plus t squared times the square of the sine. I think you'd probably get the sign correct, although those expressions are certainly here, but you have to write the square of this expression, okay? And that's going to also give you a negative 2t sine t cosine t. And then you're going to have an e to the 2t from the e to the t, that's the square of e to the t. And you're going to have a cosine squared t from here that'll match up with the cosine squared t that you do get when you square this expression. And you end up with e to the 2t plus 2 cosine squared t minus 2t sine t cosine t plus t squared sine squared t, which I wrote down here, didn't write down here, but implicitly this goes here. Okay? So now, what's the parallel component of your acceleration vector? That's the component of the acceleration vector parallel to your unit tangent vector. Now I have to digress a little bit to talk about this because there's stuff that people really need to be on top of right now at this point of the course with a test hanging over your head that people didn't seem to completely remember from when we did it a few weeks ago. It's easy enough, you'll remember it, but I have to talk about it before I can talk about this, so we'll continue in the next clip.